So I'm going to create a couple more cells here, and I'm going to upload a new image that we haven't actually seen yet, and it's an image of a gorilla. We will say CV2, imread, and inside your data folder, wherever you happen to have it, we're going to upload gorilla JPEG, and we're going to upload it as a grayscale. And let me also just get the display function working. I'm going to copy and paste the display function from the notebook. Again, this is the display function we've always been working with, display image or display. So I'm going to run that, and let's display the gorilla. So we'll display gorilla, run that, and actually let me clarify the CMAP is equal to gray. Run that, and so here we have this picture of a gorilla. It's quite a large image. If we actually check out the gorilla shape, it's about 1300 by 2000, more or less. So what we're going to do now is calculate the histogram, and then we will equalize the histogram and visualize the difference. And then we'll run this again on the color version of this image. So let's first do this in black and white. What I'm going to do is just calculate the histogram values here. We will say hist values is for the gorilla image is CV2. Calculate hist. Say gorilla. Channels 0. Because we're just focused on one channel, it only has one channel, it's grayscale. We're not doing any mask, we'll say mask is none. Hist size is equal to 256, and then the range is equal to 0, 256. Okay, so whoops, range is, there we go. Then the next step is to simply just plot out those values. So we will say plt plot hist underscore values, run that, and there we see the actual histogram. So here's the histogram on the grayscale image. Looks like we have a lot more kind of lighter colors and then a couple of darker colors, but not so much pure black. And if we take a look at the image, it looks like a big chunk of those lighter colors are from the rock behind this gorilla. And the gorilla itself is actually pretty light colored. There's nothing too dark or too black. Maybe a little bit around its fur and a little bit around here on the edge. But really we can see here, there's just that little spike of dark, but most of it seems to be a lighter gray. And I can tell just because this is a grayscale image. Now let's show you how we could equalize the histogram. So I'm going to make a version of this called equalized gorilla or EQ gorilla. And the command is actually really straightforward. It's just you call equalize hist, and I encourage you to tab autocomplete that, and then just pass in gorilla. And first off, let's just display what that result looks like. So I don't actually even need to calculate the color histogram to do this. I can straight up just call it on an image and then display the result. So notice just how much the contrast has been increased here. So when we equalize the histogram, we've definitely increased the contrast. Notice now that those light grays are essentially now the minimum value of 0, and those darker values kind of around the hair and fur and over here on the edge, those are now the max values of black. So compare these two images, we get a lot more color depth here in gray, and upon equalizing the histogram, now you see a much higher contrast. And if you wanted to, you could then calculate the hist values for the equalized gorilla and display the result. So let's go ahead and calculate that. I'm just going to copy and paste this command, except now I'll pass in the EQ gorilla. Run that, and whoops, make sure everything's okay. EQ underscore gorilla. There we go. And we'll say plt plot hist values. And now notice the behavior you get. So you get these constant spikes down because there's 0 value there. But if we compare this to our original, it's definitely been more flattened out. So we can see here that we tend to kind of quickly decrease as we go past 50. And then if we come back down here, the decrease is much shallower as you go beyond 50. So it's a much shallower drop compared to the original image here, where it was a much quicker drop. Okay. So that's the difference, and really the effect is a higher contrast. And keep in mind, you can actually do this exact same thing for a color image. So the way we do that is first I'm going to read in the color gorilla. So I'll read in the image again, except this time I'm just going to read it in as a color image. We'll say CV2 imread data / gorilla. And if I want to show the gorilla, I'll create a show gorilla where it's converted to the correct color space. So we say CV2 color, pass in the color gorilla, and then say color underscore BGR to RGB. So let's display what the colored version of the gorilla looks like. We're going to say PLT. In fact, we can actually just use the display function we defined. we'll say display or show gorilla. So this is what the color version of that image looks like. So here's the gorilla, it's in full color. If we actually want to equalize the histogram of a color image, essentially increase the contrast of the color image, the way OpenCV works is you actually translate that first to an HSV color space. Remember, that's the hue saturation value. So I mentioned earlier, we really wouldn't be dealing too much with HSV. This is one of the few instances where we do, just because of the way the equalize histogram function works. So what we will do is create an HSV version of the gorilla. We'll say HSV is equal to CV2, and then change the color space of the original color gorilla that we read in. And we're going to change it from the default blue, green, red to hue saturation value. So we have this HSV version of the gorilla, and then what we're going to do is grab that value channel, because the value channel is really the one we're interested in. So we'll say HSV : and the 0 channel, that's the hue, the 1 channel, that's the saturation, and we're interested right now in the value channel. So this is going to be our value channel right here, and if you check out kind of the min and max values here, these are the ones that go from 255 to 0. So what we're going to do is we're going to equalize this value channel. So I will copy and paste right here, and then I'm going to set that equal to the results of CV2 equalize histogram of that particular channel. So I'm taking that value channel, equalizing that value channel, and then replacing the original values. So we're going to run that. And then what I'm going to do in order to display the results, I'm going to convert this HSV gorilla to the RGB that we're used to. So we will say the equalized version of the color gorilla is equal to CV2, CVT color, HSV, and then we're going to take that HSV and then convert it to color space from HSV to red, green, blue. And now I can display the equalized color gorilla. And now we see here much higher contrast than in the original color gorilla image. So if we come back up here, we have a lot more color depth. It seems to be a little darker. And then when you come around here, now notice the rock behind the gorilla is much brighter. And over here on the edges, it's much darker. So we increase the contrast. And we're able to do that simply by just isolating that value channel in the HSV, applying equalize hist, and replacing those original values with the equalized histogram version, and then converting it. This is just for display purposes to RGB, and then we have our high contrast gorilla. Okay, so in this lecture, we learned how to equalize histograms to create higher contrast images, as well as how to apply masks to only calculate the color histogram for a particular section of an image. That ends our discussion on histograms. We will see you at the next lecture.